Last class we were discussing about R firing circuits. So today we will see what is RC firing circuit. So in the basic R firing circuit you have a source, then there is a load. This is SCR gate terminal and this is cathode and anode. So R means between gate and cathode you will be using only resistive network only. Okay, so this was R2, there was a protective resistance R1, here it is R, and if it was half controlled or half wave controlled, then you will be using a diode also, but the major components include resistors only. That's why this firing circuit is called R firing circuit. One of the drawbacks of this R firing circuit is that the maximum firing angle, normally we denote firing angle by a letter alpha. So whenever I say alpha, you have to understand that this is equal to firing angle. So maximum alpha in this case for this R firing circuit is up to 90 degree only, which means if this is input voltage, this is 90 degree, you can control only up to 90 degree. If you want to control at 110 or 170 or at 180, it's not possible with R firing circuit. So we are going to see RC firing circuit and check in this condition or in this circuit, is it possible for the firing angle to go beyond 90. Okay, so first I am going to draw the RC firing circuit half wave, then I will explain full wave circuit. So basic circuit remains same. There will be a source whose instant of turn on at positive half cycle that will be controlled. This is basically the load. Again SCR with anode, cathode and gate. Okay, now between this gate and cathode, this is gate and cathode. Previous case this was a resistor, now here I will be using a capacitor. Okay, to charge the capacitor I will be using a variable resistance R2. Okay, I am going to control the positive half cycle. This is half wave. First of all I am explaining the half wave. So I am going to control only the positive half cycle of the input voltage, so I don't need the negative half cycle, so I am using a diode here. Okay, which means when the negative half cycle, during the negative half cycle the capacitor path will go like this, capacitor, diode and things like that. So during that half cycle, in the negative half cycle, when it conducts, the gate and cathode junction of an SCR may also damage. So to prevent the damage, I also will be using a resistor diode here connected in this way. Okay, now the detailed working of the circuit. When I explain the working, you will understand the circuit more. So first I will draw the waveforms. Okay, so start with the positive half cycle, negative half cycle, positive half cycle, pi, 2 pi and 3 pi. To explain the working, I am also going to draw a negative half cycle also. This is 0. Okay, now project it downwards. So before understanding any firing circuit, you need to understand from the data sheet what is that value of VGT, required voltage to turn on the SCR. From a data sheet you need to obtain the data. So I have calculated, so I have noted down this VGT from the data sheet, and I observed that this is equal to again say 1.3 volt, which means whenever the voltage across the capacitor reaches 1.3, SCR will turn on. That's the meaning. So I am also going to mark this VGT here. In the same graph itself I am marking VGT. So let's say this is 1.3 volt. Okay, so this is the axis omega t and this is the voltage magnitude, input voltage Vs I am drawing. Okay, now what will happen during the first negative half cycle? I am taking the first negative half cycle, this negative half cycle. Okay, so what will happen during the first negative half cycle? So negative half cycle means here it is minus and here it is plus. Okay, so the circuit, the current will flow like this to the capacitor through the diode into the load and back to, which means there is no charging circuit like a time constant circuit for the capacitors. Capacitor is directly exposed to the supply voltage, so capacitor immediately follows the supply voltage. Capacitor voltage also, this red line is a capacitor voltage, so capacitor voltage also reaches and it reaches a peak value. Okay, once the capacitor voltage has reached the peak value, so plus here and minus here, and after that the capacitor voltage start decreasing. Okay, the capacitor voltage start decreasing, so immediately we can say that what happens to this diode D, that you need to study. This is the happening the negative half cycle. This is what is happening in negative half cycle. The capacitor simply charges to supply voltage peak. Okay, and what happens during the positive half cycle of the supply voltage? Okay, so during the positive half cycle of the supply voltage, positive half cycle of the supply voltage means here it will be plus and here it will be minus. So you can see a charging circuit from the plus terminal load R2 to C. You can see a charging circuit. So from this point, okay, from this point the capacitor voltage can go to this value, positive half cycle peak. That's the idea. But it can take several paths. Like it can go like this, it can go like this, it can go like this, it can go like this. Okay, you can in a very short time you can increase the voltage to this extent, or the capacitor also may take some time to reach this extent. This all depends on the value of this RC. This RC generally known as the time constant of the circuit. Okay, so if the time constant of the circuit is very high, the capacitor may take this path. If RC is very low, the capacitor may take this path to reach, okay, plus Vs. And the idea is when it goes to plus Vs or plus Vm, it will cross this VGT at different intervals. What's the meaning once it crosses VGT? The meaning is that when it reaches the VGT value, immediately this junction will break down and SCR will turn on. That's the meaning. Okay, so I'm going to draw one example. Okay, I'll redraw this. So first you draw the negative half cycle, positive half cycle, negative half cycle, positive half cycle. So this is 0, pi, 2 pi and 3 pi. Extend it downwards. Okay, I'm also going to mark this VGT. Assume that this is VGT. This much voltage is VGT. Okay, now the capacitor voltage VC also you can draw like this. In negative half cycle the capacitor follows the source voltage, but in the positive half cycle, first I am telling the RC value is very low. RC is very low, the value of R is very low. That's why you are using a variable resistance. You can control the value of R. So what will happen if RC is very low? Which means വളരെ പെട്ടെന്ന് ഈ കപ്പാസിറ്ററിന് ഇങ്ങോട്ടേക്ക് എത്താനായിട്ട് പറ്റും. So the capacitor may assume that it is taking this path. Okay, it is going to reach this plus Vm, but on its way it has crossed this VGT. What happens once it crosses this VGT? Immediately SCR will turn on. SCR will turn on means what? The switch is on, the gate cathode junction breaks. So immediately what will happen? The voltage across this device will be equal to 0. Capacitor is connected parallel to that device, so immediately the voltage across the capacitor also 0, reaches to 0 for the remaining half cycle. So at this instant SCR will turn on. Okay, so during that interval, once SCR has turned on, we can easily draw what is output voltage and what is the voltage across the thyristor. I have given you the formulas. So if you remember, the formula is once the device is turned on, the switch is on, output voltage is equal to supply voltage, no matter of what the type of the load is. Similarly, when the switch is on, the voltage across the switch is 0. When the switch is off, the voltage across the switch is equal to supply voltage. That was the rule. So at this instant it is on. So before that, what is the condition? Output voltage, SCR was not turned on, so output voltage was 0. At this instant it is turned on. What's the meaning? The turned on means output voltage is equal to supply voltage. So ഈ ഇൻസ്റ്റന്റ് മുതൽ എന്താണോ നിങ്ങൾ സപ്ലൈ വോൾട്ടേജിൽ കാണുന്നത്, ഇത്ര ഒരു ഏരിയ ആണ് കാണുന്നത്. Okay, so you can copy this and you can draw as the output voltage. Okay, what happens to the thyristor voltage Vt? So until this time SCR was off, which means the switch was off, the voltage across the switch is equal to supply voltage. So until this time you are seeing supply voltage like this. ഈ ഒരു പോർഷൻ മാത്രമാണ് supply voltage. So you can draw this. Okay, and after this instant SCR is on ആയി കഴിഞ്ഞാൽ the voltage across SCR will be 0. So that is 0. Okay, the meaning is when you add this V0 plus Vt, you should get the full supply voltage. Okay, now what happens in the next negative half cycle? Again the polarity changes. The negative half cycle, capacitor will charges to the negative voltage. The cycle, whatever we have seen in the cycle, just repeats. The capacitor hold to the peak value, and after that it stays there. Okay, and the next positive half cycle, what will happen? The capacitor will take this path, again a trigger, this goes on. Okay, so until this time, once it is on, in the negative half cycle, this is a negative half cycle switch is off, right? Because negative half cycle, anode is negative and cathode is positive, SCR cannot turn on. So output voltage is equal to 0, negative half cycle here, ഇവിടെ 0 ആണ്, and this 0 will reach until this point, ഇവിടെ വരെ അത് 0 ആണ്. Okay, and after that it is equal to supply voltage. ഇവിടുന്ന് കാണുന്ന ഈ പോർഷൻ ഇങ്ങോട്ട് കോപ്പി ചെയ്ത് വരയ്ക്കുക. Okay, what happens to VT? ഈ ഒരു പോയിന്റിൽ എത്തിയാൽ പിന്നെ എന്താ? Output voltage again falls to 0, which means SCR is in off condition. So voltage across SCR will be equal to supply voltage. അപ്പോൾ ഇവിടം മുതൽ ഇവിടം വരെ ഓഫാണ്, ഇവിടം മുതൽ ഇങ്ങനെ വന്നു, ഇവിടം വരെ ഓഫാണ്. അപ്പോൾ ഇത്രയും ഇൻസ്റ്റൻറ്റിൽ കാണുന്ന ഒരു ഏരിയ കോപ്പി ചെയ്ത് മുകളിലേക്ക് വരയ്ക്കും. ഓക്കെ, ഇതാണ് നിങ്ങൾ കാണുന്നത്. ദാറ്റ് ഈസ് ഈക്വൽ ടു സപ്ലൈ വോൾട്ടേജ്. കോപ്പി ചെയ്ത് വരയ്ക്കുക. So in this way we can draw the graph. So this is all about RC half wave circuit, and I will also explain the circuit of RC full wave, and you can draw it in the textbook with different firing angles are also given. Okay, when RC is very low, when RC is very high. So the full wave circuit is it's very simple. First of all, I am going to rectify it. So you can use a diode rectifier. Okay, bridge diode rectifier. You will be connecting your supply here. So across the output of this diode rectifier, you should get a rectified supply voltage. This you can directly connect to the SCR. The circuit is very simple. Gate and cathode, anode, this is RC value. Okay, and of course you can use a load here also. So this part, instead of directly connecting the supply voltage here to the load, I have replaced with a diode rectifier so that I will be getting the rectified voltage, which means both positive and negative half cycle the capacitor will be charging. Okay, so I will draw the waveforms also. Supply voltage, this is a supply voltage, and this is a rectified voltage. Okay, and I am going to mark this VGT here. Now let's see what happens to the capacitor voltage. Capacitor slowly charges in the this is the cycle. This is rectified to this voltage. So during the first positive half cycle, the capacitor is charging to this voltage through this R, and it can take this path, this path, this path. It all depends on the value of R and C, time constant. Suppose it is taking this path, capacitor is going up to this point, and after that it is on, so the capacitor voltage reaches 0. Again it takes this path in the next negative half cycle, but here it is a positive half cycle because it is a rectified voltage. Capacitor again charges to this value and then on. Capacitor again charges to this value and it is on. So using that you can draw the output voltage. ഇവിടെയാണ് ഓൺ ആവുന്ന ഇൻസ്റ്റൻറ്റ്. സോ ഓൺ ആവുന്നിടം വരെ ഔട്ട്പുട്ട് വോൾട്ടേജ് ഈസ് ഈക്വൽ ടു 0. ഓൺ ആയി കഴിഞ്ഞാൽ ഇറ്റ് ഈസ് ഈക്വൽ ടു സപ്ലൈ വോൾട്ടേജ്. റിവേഴ്സ് ഇസ് എ കേസ് ഫോർ തൈറിസ്റ്റർ വോൾട്ടേജ്. അൺടിൽ ദ സ്വിച്ച് ഈസ് ഓൺ, it is equal to supply voltage, and after the switch is on, it is equal to 0. So you can draw this using the textbook. Waveforms are neatly given, so you have to draw the waveforms, and you also have to